Lewis dot structures for ionic compounds. So let's start by looking at sodium. So sodium has the electron configuration shown here, and it has 11 protons and 11 electrons. This means that the charge on sodium is 0. So to draw the Lewis dot structure for sodium, first we put the element symbol, and then we place dots around the outside to represent the number of valence electrons. So sodium has 1 valence electron, which means that we're only going to need 1 dot. And the way that we place the dots, there's a pattern. So it goes top, right, bottom, left. And since sodium only has 1, we're just going to put 1 electron on top there. So sodium only has 1 valence electron, and 8 is what we would need to be stable. So we could either lose a valence electron, or we could gain 7. It's going to be easier for sodium to lose an electron because it has a low electronegativity value. So sodium is going to get to an octet by losing this 3s1 electron. Now we have 11 protons and only 10 electrons, so my charge is now +1. So whenever we do our dots for sodium, we're going to go top, right, bottom, left, top, right, bottom, left. So after we make an octet, sodium has these 8 valence electrons. Go ahead and pause the video and spend some time to work on magnesium and aluminum. So magnesium has this electron configuration, and with 12 protons and 12 electrons, it has neutral charge, 0. And so we have 2 valence electrons this time for magnesium. So once again, how is sodium going to get to magnesium going to get to a full octet? So it only has 2 valence electrons, and it has a pretty low electronegativity. So it's going to get to an octet by losing those 2 electrons. Once we've lost these 2 electrons, the charge is going to be +2. So again, when we draw our octet, remember, top, right, bottom, left, top, right, bottom, left. Now looking at aluminum, aluminum has 13 protons and 13 electrons, and 3 of those electrons are in the valence shell. So we have the 3rd energy level, which contains both s and p electrons for a total of 3. So top, right, bottom. The charge is 0 because we have an equal number of protons and electrons. So to make an octet, aluminum only has 3 valence electrons, and it has a pretty low electronegativity. So the best way for it to reach an octet is going to be to lose these 3s and 3p electrons. So now we have 13 protons and only 10 electrons, giving us a charge of +3. So now that we have an octet here, again, remember the pattern: top, right, bottom, left, top, right, bottom, left. So why did these guys all form cations? All of these elements have pretty empty valence shells and pretty low electronegativity values. So their valence shells are pretty empty, 3 electrons or fewer. So the easiest way for them to get to an octet is going to be by losing electrons. And remember that when you lose electrons, electrons are negative, so our atom becomes positive, and we call it a cation. Now let's look at some elements that are going to form anions with a negative charge. So these elements are going to gain electrons to get to an octet. So first we have nitrogen with 7 protons and 7 electrons, making my charge 0. Now for nitrogen, the highest energy level is energy level 2, and that has a total of 5 valence electrons. So top, right, bottom, left, top. So nitrogen has 5 valence electrons. So the easiest way for it to get to an octet is going to be if we gain 3 electrons. So instead of 2p3, now we have 2p6. We have 7 protons, but 10 electrons, giving us a negative charge of -3. And then, of course, after we lose those 3, we have a full octet. Go ahead and pause the video to work on oxygen and fluorine and return here when you are ready to check your work. So for oxygen, oxygen has 8 protons and 8 electrons, giving it a neutral charge. And oxygen has a total of 6 valence electrons. So to get to an octet, it's going to be easier for oxygen to gain 2 more electrons. So instead of 2p4, now it's 2p6. We have 8 protons and 10 electrons, giving us a charge of -2 on oxygen. For fluorine, we have 7 valence electrons. So this is really close to having a full octet. So the easiest way to get there is going to be to gain 1 more electron. This gives us a charge of -1 whenever fluorine makes a full octet. So why did these atoms tend to form anions? These guys all had pretty full valence shells with pretty high electronegativity. So they're going to be able to attract electrons to get to an octet. And when an atom gains electrons, electrons are negative, so we form a negative anion. Now what about neon? Would neon form an anion? So neon is atomic number 10, and it's a noble gas. So it already has a full octet. It already has 8 valence electrons. So it doesn't need to gain or lose any electrons. So it's not going to form an anion because it already has an octet. So we've practiced drawing Lewis dot structures for individual atoms. Now we want to be able to draw this for a compound. So the first example that you have is done for you, and it's CaCl2. So this is telling me that we have 1 Ca and we have 2 Cls. So this little 2 here is telling me 2 chlorine atoms. Calcium is going to have 2 valence electrons. Chlorine is going to have 7. So 1, 2, 3, 4, 5, 6, 7. Also notice that I'm using different symbols here because we want to be able to tell where these electrons came from. Same thing with this guy. 1, 2, 3, 4, 5, 6, 7. So calcium is going to get to an octet by losing 2 electrons, whereas chlorine is going to get there by gaining an electron. So we can kind of see what happens. One of these electrons is going to go to this chlorine atom, and the other is going to go to this chlorine atom. So whenever we draw our Lewis dot structure, we want to try to arrange it so that we can see where those electrons came from. So you could draw it something like this. We could leave these guys in their normal spot, and then we can put our Cls. In your packet, it's drawn a little bit different, but that's still all right. And so now that we've drawn in all these electrons, we can see that chlorine has a total of 8 around it. So does this one. And that calcium has lost these 2 electrons. So we want to put these square brackets to indicate that these electrons belong to Cl. So this Cl gained an electron, giving it a -1 charge. So did this one. And calcium lost 2 electrons, giving it a +2 charge. So the sum of these charges, +2, -1, and -1, should always add up to 0 for an ionic compound. So go ahead and pause the video and work on questions A and B, drawing the Lewis structure for each. So looking at sodium bromide. Sodium's electron configuration has 1 valence electron, whereas bromine has 7. So I'm going to put my 1 dot for sodium, and then I'm going to put my 7 dots for bromine. So we could kind of see what's going to happen here. Sodium is going to donate this 3s1 electron to the 4th energy level of bromine. So that gives us this Lewis structure. Don't forget to put your charges and to put a square bracket around your anion here. Next we have Mg and O. So magnesium has 2 valence electrons and oxygen has 6. So we can kind of see how magnesium is going to get to an octet by giving away 2 electrons, and oxygen will get there by gaining those 2 electrons. So 1 electron will go here, 1 electron will go here, and so here is our Lewis dot structure. We want to make sure we put the charges and the square brackets. So magnesium will form a +2 charge from losing 2 electrons, whereas oxygen will form a -2 charge from gaining 2 electrons. So the next couple of elements here, we have Na3N. Remember that those subscript numbers tell you how many. So go ahead and pause the video and take a couple of minutes to work on C and D, and return here to check your work. So Na3N, we're going to have 3 sodiums and 1 nitrogen. So I'm going to draw 1 dot for each of my sodiums. Notice that I'm color coding here. And nitrogen is going to have a total of 5 valence electrons. So we can kind of see what's going to happen. Each sodium is going to donate an electron to nitrogen. So 1 will go here, 1 will go here, 1 will go here. So our final Lewis structure is going to look like this. Don't forget charges and your square brackets. So it's best for you to draw it like it is here so that we can see, each pair of electrons. But if you drew it kind of all in a line, that's all right too. But this is better the way that it's shown here on the screen. Okay, next we have AlF3. So we have aluminum and we have 3 fluorines. So aluminum has 3 valence electrons, whereas fluorine has 7. So we can kind of see what's going to happen here. Aluminum needs to lose 3 electrons. Fluorine, each of them needs to gain 1. So these 3rd energy level electrons from aluminum, we're going to give 1 to each of these fluorines. So 1 here, and 1 here. So again, don't forget to write your charges. And don't forget to put the square brackets around the electrons. This is just to make sure that we indicate that these electrons belong to this atom. So what does this look like in reality? So whenever we write a Lewis dot structure or a chemical formula, we write it like it's only 1 pair of ions. So for example, NaCl, we write it like it's 1 sodium atom and it's 1 chlorine atom. But that's not what an ionic compound is arranged like. Instead, they form a crystal lattice structure of ions. So we have this alternating negative, positive, negative, positive. So this arrangement is going to be the most stable because it prevents any of those like charges from repelling each other.